We will use the next 40 minutes to talk about one case study, and that will be from SAAB Kockums, who is starting to explore the model-based something, whatever we decide to call it. So it's me, Håkan Kodén, and Torbjörn Pettersson, who's in IT in SAAB Kockums, and also Mats Nilsson, who is in ILS, or Technical Information. Just a few slides from me. I will start with a few slides, and I will end the whole session with a few slides as well. We have been here for a couple of years. In 2014, we were talking about Siemens Energy using ShareSpace for external collaboration with suppliers. 1 year later, we had the Volvo Trucks on stage, who talked about secure collaboration with joint venture partners using the ShareSpace software, which is based on this PLC standard that we will hear a lot or more about from SAAB Kockums. 2 years ago, we had Volvo Cars describing what they are doing in terms of collaboration internally inside the Volvo Group after they were acquired by Geely, also using our software. Last year, we had the Renault Cars, or Group Renault, here doing a presentation, and they talked about internal integration inside Renault, from design to manufacturing, from basically a Dassault system environments to a Siemens environment. And they also presented ideas about external collaboration. And we are happy to say 1 year later now that we have these systems in production. If you want to hear more about that content, you can actually, it's available on the eurostep.com website, and I think it's also available on the PI TV website, that recording from last year. I think that's it. So basically, I'll introduce SAAB Kockums by using a video.
Good day, everyone. My name is Torbjörn Pettersson, and I'm here together with my colleague, Mats Nilsson, to talk about the case study that we have done within Kockums. We will talk about internal and external information management in this context. We have divided this presentation into two parts. I will start off with an IT view of the case study, IT as an enabler for the actual case study. Before I show some slides of the solution that we have ended up with, I would like to take a few steps back and show you where we came from and our approach towards the solution that we use today. We have this scenario, and I'm quite sure that many of you recognize this type of system environment. A lot of point-to-point integrations, a huge amount of different systems in use. Needless to say, this type of system environment is a very complex environment to integrate the different systems to each other. You have all the hazards with different versions, upgrades, interfaces, and so on. It's also very hard to exchange data between the different systems in use. Not only due to the integration complexity, but also that all the different systems have their own information models, for instance. And to state the obvious, we of course have a very complex and quite costly IT environment to govern in this type of situation. And of course, this drives long lead times if you want to change something or if you want to upgrade something, system in this type of environment. You can easily end up in some sort of catch-22 situation when it's quite hard to do an upgrade. Another issue that is very crucial for us is that our products have a very long lifespan. It's not unusual that chips are in service for 40 to up to 50 years, actually. And of course, we change our systems supporting the product information in those vessels much more rapidly. But we still want to get hold of the information contained in the different systems and reuse that in a smart way. A product for us it's not only a new build, but a product goes through several projects during its lifetime. We have overhauls, we have lifetime extension periods, big maintenance scenarios. We even can strip, for instance, a submarine of all its interior, almost all of its interior, and put new stuff in and sell it to another country. That is a thing that we do as well. And of course, then we have the complex nature of the product data in itself, illustrated in this picture by a pump. This pump appears in many shapes and in a lot of different systems, of course, in our vessels. So we have to manage our product information from a lot of different views. We also have to meet the needs from a number of different disciplines, from the early phases in design, production, procurement, and also in service. And there is also, of course, many dependencies between the different information sets in a complex product. And the guys who are working with this from design to in service always change a lot of things all the time. That goes with the territory, but we have to keep track of that, and we have to baseline all the information for being able to be transparent. We also saw the information to be locked in different softwares, and that it was hard to get it out from the actual software. I mean, you can produce an information set in one software, but you want to consume it in other softwares as well. So, our approach to change this situation then. The challenge is to provide a lot of stakeholders with relevant information and do it fast. We mean organization, and by that we mean not only internally, but also suppliers and customers and partners. All the different disciplines that I mentioned before. We want to create and exchange and access information independent of the software you use. And one thing that we have seen as a critical issue is the concepts and terms. We are trying to illustrate this by this pyramid here. And we try to do a bottom-up approach, you can say, starting with the concepts and terms. All the layers here, I should say, in this pyramid is represented by a model. So we have a concept model, we have information model, process, organization, and tools, the software models. So our idea was to create a common product language. We want, I'm quite sure that you have recognized the situation where you talk about things with a colleague, or you think you're talking about the same thing, but you misunderstand each other. It could be equipment, systems, parts, whatever. That also goes when you try to integrate systems in an environment, of course. So we try to define a common language within the company, and we have done so. You see a small portion of the concept model here. It's not a dictionary, it's not a list of words, it's an actual model where we have relationships between the concepts. Currently today we have approximately, I think, 80 concepts in the model, the most crucial ones that we need for product data. This concept model is then mapped to an information model. And those two models helps us to facilitate the integrations between the different systems. So, we ended up here. We have chosen a backbone solution based on a product from Eurostep, a ShareSpace. It's a PLCS-based backbone. This gives us a standardized solution. It simplifies our integrations. It also increases the possibilities to exchange systems much more easier than in the previous scenario. We can be transparent with the information between the different systems. We transfer information via this backbone according to certain rules, of course, and based on this concept model and information model. This gives us the possibility to be transparent with the information between systems rapidly, to get a good baselining of the information in the product. Of course, this is some sort of idealized picture. We have still systems that are not attached to this backbone. When we have done this, no, I should just go a little bit further. Yes, we have this picture as well, showing just shortly how we integrate towards the backbone. We use what we call a backbone XML format. It's a simplified format to transfer information from the different systems to the backbone. In the backbone, we have all the rules, the consolidation rules and import rules and things like that, consolidation of the data. And at the end of the local software connected, as it is called here, we use the concept model to mapping the information objects contained in the different systems. So now we have a solution where we can communicate internally between our systems. This thing that we have here is now up and running, and you will see some examples of the softwares that we have connected to the backbone in Mats Nilsson's presentation later on. We wanted to extend this, of course, to start communicating with sub-suppliers and partners and customers. So, shown in this picture, there we want to use a different format, a different information contract, DEX, Data Exchange Specification. Those DEXs are written to support a certain business area, you can say. You will also see more about that in the concept study. The DEXs are often written according to associations and to a certain customer. In our case, the Swedish Defense has written a number of DEXs that we use to communicate with them. So a collaboration scenario could look like this. At the lower end of the picture here, you see Kockums, our internal systems. You see our ShareSpace symbol there. That is the backbone. And to the right side on the picture, You see our sub-suppliers, that we can import the information from them via this format. And then we can use this DEX format to communicate to our customer, the Swedish Defense, and also the end customer, the Swedish Navy in this case. And you have also a list of the exemplified DEXs here: fault definition, maintenance report, operational data, requirements, and so on and so forth. This list of DEXs is getting longer and longer by the time. So by this, I think I've given you some sort of insight of the IT solution that we use. And now you will see some more examples of the actual case study. Thank you.
Yeah, sorry. Dear all, my name is Mats Nilsson, and I'm the head of technical information at SAAB Kockums. I will show you some operational issues now, operational view, as a continuation of what Torbjörn described here. The data handling enablers and architectural solutions. Just a little note here that at Kockums we often say that we are good at stealth, and that's proven that I'm not within the speakers list, so you won't find me there. But I'm here for the moment. I will go through these bullets, focus on the naval technical information at SAAB Kockums, focus on the deliverables to the Navy and the new way of delivery with example pilots, the DEX pilots we call them. And as Torbjörn indicated, we have customer and we have end user. And actually, I think this is a very important picture for me, because these are my real customers. These are the crew. They are very demanding customer. They need spare parts, tools, training documentation, information and paper, and in files. They still use paper. They require paper, also in our latest projects, but also XML files, of course. On a submarine, this is not a submarine you see here. On a submarine, the most important piece of information is actually the pipe schematics, which they have in their pocket, their leg pocket. Because if something bad happens, you can't rely on battery or electrical things. So you need to be quick. So that's why we are both in the future and in old school, as has been said here, that word. So that's also a challenge. Yeah, the PLCSS is the driving engine for the deliverables to these users. The correct information, as it states here, this is actually the precondition to operate and maintain these complex products with very long life cycles, as Torbjörn said, 30, 40, 50 years. Actually, we have a customer that uses a 52-year-old submarine in another country, which has, of course, been upgraded. Okay. I will make a little stop here and show you the basis of our product development process, maybe in another view that you're used to. You're not supposed to see this picture, actually. It's just a hint of that FAV, the Swedish customer, they develop the requirements. Most other clients, they would like to do that as well. They're close to the scenario, the missions, the use cases. That's their ballpark. We receive those requirements, of course. We work with the requirement specification. We break it down. And then we start to work in increments. So through the study phase, the conceptual phase, the design phase, we more or less work with those axes: the general arrangement, the hull and hull equipment, the energy systems, the auxiliary systems, the payload, weapons and combat systems, and also, not least important, all the interdisciplinary departments. Because they are those that really make a difference. Shock resistance, EMC capabilities, hydroacoustics, hydrodynamics, and of course ILS. Dependability, maintainability, information packages on board, ashore. So, when they have done their job correctly, we get the production and installation information. That is what we reuse as product data with the help of the ILS plan and the plan for technical information. And of course, if you use ASD, S1000D and stuff like that, you need business rules to take care of the information, to create the red thread, the digital thread. So here you have other access, and those are part of the product baseline that is required from the Navy and from the FMV, the Defense Material Organization. So then we start to doing our increment. And as soon as we get information according to a plan from different areas of the design discipline, we start working with the information. We put together the piece of the puzzle: material register, supply data, system descriptions, installation catalogs, and so on. And then we come back down to one very important thing, the spare parts catalog. We also have of course, what is supposed to be on board, the kit and accessories, spare parts, other stuff, also from the end users, their own supply. We need to have list on that on board as well. Printer matters and support from the configuration and change management, of course, on each row, or each round. We make a check. Has something changed? Do we need to redo something? And slowly, when we come to the middle here, we deliver a preliminary review release to the customer, to FMV. And further on, the reader's proof, the review release, which is very important to be able to leave the shore, to start the harbor, to start the sea acceptance tests. And finally, the final release. So, and if you superimpose, if you overlay these two processes, these two helixes, and you stretch them out in time, you get maybe the classical view. This is the product life cycle, drawn in another way. We start with the design. We hopefully have something to reuse. We have digital ships from before. We try to reuse information, otherwise we have to create new information. So actually we have two life cycles here. We have the information life cycle, and we have the product life cycle. We have the digital ship in the below and the physical ship above. So design is, in this aspect, quite a short moment in time, because what you do there, you are building and maintaining for 30 to 50 years, I wrote here. The design information is taken care of. That design helix is triggering my helix, my technical information helix, and we start producing maintenance and technical information. We start to deliver as soon as possible, actually, to be able to make incremental review and feedback or comments. After delivery, we aim for the 2-year overhaul intervals. That's on the A26 submarine. That is a customer requirement. Every second year, there's an overhaul. We also put in some modifications. So we activate design work, and as soon as that is done, we activate the technical information work, and we deliver it to the digital model. Until the bitter end, the physical ship has reached the end of life, is chopped into pieces, but the digital chip still lives. And the question is, what do you want to do with the digital chip? And what could you do with it, actually? Because a lot of old systems, locked in data, we need to, so to say, open up. How shall we reuse it? Yeah, then we have to reach it and restructure it. Because, as also Torbjörn said, we have one product, but we have many, many projects. One project is study, one is the projecting, another project is design and build, and then we have all the modifications. That's one small project. Also the overhaul, half-time upgrade is a quite big project. So we need to take care and differ between the product data and project data. And that's also a challenge here in this perspective. Okay. The current technical information exchange solution. Yes, we have worked together with the Navy for 336 years. Not using XML format all the time, I can tell you, but the latest years. But the publication structure, nevertheless, what the format and what the systems, they want to have a certain publication structure. Well practiced over the years. The structure, the content. Today we have a reasonable good information availability. If we stick to the sub-suppliers that are used to us, they know expect what to do. But the problem is that we discussed this in some form that they are replaced by new ones. We get end-of-life issues here for our systems and components. We use XML format so we can actually have a reasonable information scalability. But of course, there's room of improvements. But because today there's different formats, different sources, different delivery systems. That's why the PLCS DEX is on the map here. A little high-level picture of what Torbjörn, Mr. Pettersson showed you is actually this one. We deliver information according to the PLCS and S1000D, according to the product baseline. We have tested different scenarios, delivering this to the FMV PLM solution. And they, in their turn, they deliver information to the Swedish Navy by a system called PRIO. And they also have a system that they also have on board on the vessels, existing and the future ones. The one on the below is the A26, which you saw were in production here in the film. We are getting the feedback data is actually, we get requirements, of course, from the FMV. We get product information because they could have information that we don't have because they have done other upgrades on another companies as well. They are free to do that. Review comments and also operational and maintenance feedback. But that's tricky to get because that is classified information actually from the Navy. This is a little detailed picture of Mr. Pettersson's. Here I actually showed you the systems which we are making internal integration upon. And here you can see different DEXs. We have shown this before, and I will make a short list. This is actually coming from the information that you can find in Eurostep stand, but the benefits here is the control delivery mechanism. Reduce lead times and establish a generic solution. So we have made one pilot last year. We will make a new one in 2018. And then we will test furthermore 3 DEXs. So what we have done is a new building contract to go from document-based to model-based and use the PLCS and DEX to clarify roles and end up in a collaboration process, which we have a first draft upon. The conclusion is, yes, it's possible. Yes, we can map data. We have gained experience in mapping the existing LSR information, technical information. We have good input to a collaboration process with roles. We have input to business model for a collaborative perspective. And also been thinking about the information security issues. With an open platform, can't be too open. We have to regulate that in some sense. And of course, you can change contracts as well. But the DEXs are an information contract in itself. So that's kind of an appendix to the business contract. So, last picture. The new pilot, we will test a new scenario to put in a new system in an old product. It will be done as a shadow project to a real customer project. So the product manager doesn't know that yet, and please don't tell him. You have heard it before him. We will do the setup for more DEXs in a share space in Reach, as said. We will do the setup for test environment and to develop a role play. We will do everything in Kockums systems that we will simulate as two parties, Kockums and FMV. Okay, Håkan.
Thank you very much, Mats. That was your last slide. So I will end up with 2 slides, and then we keep the time, I think. Eurostep in a few words. We are totally focused on collaboration process and mastering collaboration data. And in this presentation, it was about security. And I was initially mentioning when we are talking about Renault cars, Volvo cars, and so it's a lot about when you start to share and exchange data with external world. It's a lot about security, of course. Call it export control or ITAR and so on, but we are supporting that. Sometimes we call ourselves that we are working on the backbone, and this was Torbjörn's initial slides was more about the backbone approach. Mats entered into this collaboration hub when there's a need to share data with external customers. We had a good, just some marketing words, we had good revenue or growth of license business last year. This year, in this spring, we're going to release a share space version or a template for knowledge transfer, which is really addressing working with external world, sharing knowledge, but not maybe everything you can share, but enough to have a good partnership up and running. Good for joint ventures and collaborations. We're going to release a share space templates that is targeted for export control and ITAR. Highly relevant in this context and in other presentations I heard today as well. And we're going to put share space as a cloud-based service. It's a standards-based software, as you could hear from the PLCS discussions here. It's about best practice. It's about openness and no vendor lock-in. Meet us at the booth. The SAAB Kockums people are here today and most of tomorrow, I think. So if you want to talk to them or to us, meet us at the booth in the exhibition. And I think that was well-kept time, Oleg, don't you think so?
I think so. You've been doing great.
Thank you.
But you took all your time, so no time for questions.